And hello, welcome everyone. So today we're going to talk a little bit more about the async IO stuff, because last video we just played around with an experimental server and we learned a little bit about the async and await syntax. And I told you there's something called coroutines, but then again I didn't tell you very much more than that. So today we're going to explore a little bit more about what is async, what is await, and why they exist in the first place. So let's just recap what we did the last video. I said well, async and await, they are just ways of defining and running things. So for example, when you define a function like main, okay, then you run async with that. Okay, or rather you define it using async. It becomes an asynchronous function, or else known as a coroutine. And the way to run coroutines is to use the await. What await is that literally it means it waits till this function finishes running, then it continues going through the rest of the code. So in other words, it's like just running a function. Then you might ask, okay, what's the use of that? Okay, so I'd like to go through a little bit more of that in this video. So let's make a new file. So I'll call this vim a experiment or mental async io.py. Okay, it's going to be a very simple one. I'm not going to put classes or objects. I'm just going to make a function, and I'm going to import, of course, async IO. Yeah, so where were we? Yes, we'll have to import async IO first. So that's the Python async IO module. Next thing to do is, well, remember to define functions. We use the async define. Okay, of course I'll put the link in the description, this docs Python org3 library, whatever. So yeah, if you want to just do a function, so we'll type async def function1. So as usual, as it's all coding practice, we like to do a hello world, or print hello. Okay, print hello function. Literally that's what it says, print hello. And oh, why don't I have auto indent? Okay, let me set the auto indent. So vim rc. Hold on, that should be auto indent. That's so weird. Experimental async IO. Yeah, so anyway, if there's no auto indent, fine, I'll do it myself. Yeah, it's 4 spaces, I believe. Okay, print hello. 1, 2, 3, 4. Should line up with the C. The return should line up with the C. Alright, so anyway, print hello there. Oh, hello. I just call it print hello. Okay, now the auto indent comes. So that's how we do the print hello. Then of course we want to have a function to run the whole code. So I will call this we usually call this a driver function. So the driver function is just a function that runs other functions. So how do we run the print hello? You have to write await. Okay, await print hello. Oh, okay, so that's all. Then maybe return 0. That's the C++ way of doing it. Okay, because you like to return 0 at the end. Of course, there's a semicolon, but who cares? Okay, so the only thing we need to call to run this code is just to write driver. And this is the basic syntax of how to run asynchronous functions. So so if you do Python 3 experimental async IO, okay, we will have a, oh right, semicolon. I think that's why. Okay, that's why. Ah, okay. So if your auto indent's not working, probably something's wrong with the code. Okay, Python 3 experimental async IO PI. Okay. Oh, driver was never awaited. Okay. So, okay. So there's a proper way to run it. Of course, the driver file. You have to do async IO run. So you cannot just have the driver here. You have to do async IO.run of driver. Okay, so this is the proper way to do it. And then you'll just say hello. It's a very complicated way of saying hello, but it shows that these are the steps we need. So this is the function we described, and this is what we are running. Okay, so to run hello, print hello, yeah, so that's what we have to do. Now, what's the use of this? Well, the thing is that you can actually schedule functions to so-called run concurrently, or at least they seem like they run concurrently. Okay, that's why they're called coroutines, because they're routines you can sort of run together, but they're not exactly running together. So let me explain with examples. That's always easier. Okay, so let's say we have this. Okay, but before that, let me introduce the function called async IO sleep. That's basically a wait function. We saw that in the last video. Async IO.sleep. Now, async IO sleep is basically, well, so we found out that, yeah, last video we talked about async IO sleep, and that's basically, it does what it says. You're literally causing the program to sleep for a while. Okay, so that, yeah, you literally wait. So let's do something that uses that. Okay, and I'll show you why this is important part of, you know, running things concurrently in a while. So let's just run things the non-concurrent way, the way that we are used to in Python. Okay, async define count to 3. Okay, so this is called count to 3. Literally it says print counting to 3. Okay, so I will print 1, and then async io.wait or sleep. Well, I can give it some time, so I can say that I can give a default value time equals 1. Okay, so it will sleep for a set amount of time. Then I'll print 2, async io.sleep time, print 3. So what am I doing with this code? Yeah, what am I doing with this code? I'm literally printing 1, 2, and 3. So I'll first make the code print counting to 3, then I'll print the number 1. Then I'll make the code sleep for a certain amount of time, which you can set. Okay, my default time set is 1. When I put the time equals 1 thing here, it means that the default value of the time will be 1. But if you don't want to set it as 1, you can set it as any other thing you like. I'll sleep for a while. Then I'll print 2. I'll sleep again, and then I'll print 3. So that's how I do it. Okay. So after that, how do we run this function? We are supposed to use the await. Okay. We can do await count to 3. Okay. Maybe I can say time equals 0.5, for example. Okay. So of course I can put here print wait time is, and then I can concatenate and I put a string. I'll convert the time value into a string so that I can add it together. Wait time is blah blah blah. Then I can put in seconds, right? Because you always need to add a unit. So what am I doing here? Okay, strings in Python can be concatenated. Means you can put them together. I expect you to know that. So I'll convert this time into the string, and then I'll put in seconds. So let's see whether this runs correctly. So I'm going to do the run driver. Of course, I'll open a new shell, and then I can do Python 3. Okay, experimental asyncio.py. Okay, so well, Okay, coroutine sleep was never awaited, so it doesn't wait at all. So again, my mistake. You're supposed to always do await over here, especially for async IO functions. So you see, wait time is this. Of course, you can of course use await print, await everything. Is it necessary? I don't think so. Actually, I don't even know what this is we're gonna do, but let me try. So okay, it says type error. Non-type object cannot be used in await function. So you can only await coroutines. Yeah. So this is what well, we learn by fiddling around. So I'm still fiddling around. You can only await coroutines. All right. So that's something you got to learn. Okay, just by fiddling around with the code. So you see, you play around the code, you will learn more. Print functions cannot be awaited because they are not coroutines. So you can only await coroutines. That's the idea. You can only await coroutines. All right. So that's why some things we have await, some things we don't. Okay, but of course, when we define a function as async, these are definitely coroutines. So you have to use the await function to run them. All right, so let's try this 3 times. Await count to 3, maybe time equals to 0.7. Okay, await count to 3, time equals 0.9. Okay, so let's see how this code will run. So literally, it runs all this in a series. It will literally wait for this thing to count to 3 first, and then stop. It will wait for this to count to 3. Okay, so the logic is like that. Okay, we run the driver file. Okay, the driver file will start reading the code, and then you'll see this keyword called await. So you'll say, wait, let me run this function before I continue with this other function. So I'll wait print hello. So print hello will be printed first. Then after that it's done. Okay, let me continue running the code. Oh, I see this await again. It says count to 3 with a wait time of 0.5. Then it literally counts to 3 with a wait time of 0.5. And then repeat it again because it will finish seeing this. Okay, it will finish running this code, and then you'll skip on to the next line. Count to 3, time equals 0.7. 1, 2, 3. Okay. So once that's finished, the driver code will say, okay, I'm done with this part. Let me go to the next thing to do. It'll say await count to 3. Okay, we'll count to 3 with 0.9 seconds. So that's what's happening. So, of course, if I want, actually maybe I should do one more. Await is I want one more sleep. It makes the code run maybe a bit nicer. If not, it's really too fast. So 1, 2, 3, wait, 1, 2, 3, and then wait, 1, 2, 3. Okay, so this runs a lot smoother in my opinion. The other one did not have a wait time between the last number and the next number on the next function, so I wanted some wait time. So this is how you would run it normally. How about if you how about if you use it the coroutine way? Can you run these things in parallel? Okay, answer is yes. We use this thing called the gather function, and then you'll see what's the special thing we can do with coroutines that we cannot do with what do you call that? You can't do it with normal functions. So this is the special thing of why coroutines are there in the first place. So let's look at the example here in running tasks concurrently. So we have to run tasks concurrently. Okay. So over here we have a function that is a coroutine that talks about factorial. Again, you don't really need to know what's going on inside this factorial code. All we need to know is, yes, of course there's a sleep function that's being awaited here or being used here. So yeah, so this is the factorial function. And then it says, oh, there's a main or driver. This is basically like a driver. It says it schedules 3 calls concurrently. So it uses async IO gather. So remember, if you want to run things one at a time, we use the await. So we literally wait and stop the code in here before moving on. And if you want to run things in parallel, run things serially or just run things normally, we use async IO run. But if you want to run things in parallel, you have to do things like this. So print running in parallel. Okay. So how do you run things in parallel? Well, let's follow the syntax here. It says it says here, oh, we need an output letter L equals to await async IO.gather. Then you have these three functions. It's a factorial 1, factorial 2, and factorial 3. I mean three instances of the factorial being run. So let's try that with a count to 3 kind of a thing. So we use async IO gather. Alright, so L equals await. Remember, we always use await to do count routines even when we run them in parallel. Async IO.gather. So we need to actually put in the names of the functions. So one function, you need to do the the function here. So here is the coroutine factorial. Okay, coroutine or the asynchronous function, we just call it coroutines from now on. I'll just get used to the term. You gotta get used to the term. So we have the factorial being run 3 times with different inputs and outputs. However, they are not what do you call that? Yeah, you don't see the await keyword being used in over here. You just pass in the coroutine, and async IO gather will run it for you. So you don't need to put await count to 3. Okay, you don't need to do it like that. Just put count to 3. Okay, so I'll put a count to 3 of time equals 0.5. Of course, I want to make it a bit neater, so I'll put this on different lines. Okay, so that it's at least more readable. Count to 3, time equals 0.7, and of course I need to remove that comma because that's an unnecessary comma. Count to 3, time equals 0.9. Okay, so next thing to do is what we print L. So I'm just going to follow the syntax here. I'm going to follow the syntax here. Okay, L equals await async IO, and then we run the function 3 times. Okay, and I don't think I should use the word parallel here. I should use running concurrently. Okay, we'll put running coroutines concurrently. Okay, so we use the async IO gather, and then, well, let's see how this code is run. So just explain again. Previously, we ran it the normal Python way we are used to. We execute one code after another. So that is the so-called synchronous way, the normal way of doing things. But if we run it asynchronously, you'll see this async IO. We use this async IO gather to run these things concurrently. And let's see what's the difference between this part and this part. So this part is running it normally, this part is running it concurrently. Okay, let's do this experiment. So we have this counting to 3, 1, 2, 3 running normally. Okay, and what happens? It says running coroutines concurrently. So it literally runs all the first bits of the code. Okay, instead of running it one after another, you run the first bits of the code at the same time. And while the thing is waiting, you run the second bits of code. So what am I talking about? Okay, so how does this code actually work? So it will start with, of course, all of these will actually start around the same time. As you can see, well, no, not exactly start at the same time. So let's take a look at the first function that we give it, or the first coroutine we give it. Count to 3, time equals 0.5. So see, counting to 3, wait time is 0.5 seconds. So that's the first time this function is run. We give it a wait time of 0.5. So how Python will read it is, okay, since we use the async IO gather function, or we await the async IO gather, we count to 3, starting with 0.5. So we actually run this bit of code first. So we will print counting to 3, wait time is 0.5 seconds, and we print the number 1. And that is what we see here. Okay, so what happens after that? Well, we see that the sleep thing actually kicks in. Okay, so you have to wait for 0.5 seconds. Okay, so you're waiting for 0.5 seconds, but what then do you do while you wait? Now, because we use this gather function. Okay, we use this gather function. Okay, when async IO sleep is called. When async IO sleep is called, what happens is that, okay, this first count to 3 with time of 0.5 will literally sleep. Okay, so okay, I don't need resources. I'm waiting here, and while I'm waiting, what happens? Well, async IO gather will say, okay, I'm waiting for this guy to finish waiting for or sleeping 0.5 seconds. Let me find something else to do. Okay, so what's that something else? Okay, I start counting to 3 with time of 0.7. So what do? Okay, I start printing counting to 3, wait time is 0.7 seconds. Alright, so it will run this function count to 3 time equals 0.7, and you will run these 3 lines of code first. Right? You run these 3 lines of code first. Okay, so you run these 3 lines of code first. So let me explain again, yeah? So what we have so far is, okay, async IO gather will actually run these functions concurrently. So, or it will try to run these functions concurrently. But how does it run it concurrently? Well, it will use a slightly different logic. So let's think of the serial way first. So it will count to 3 with time 0.5. So it will run this function first. Okay, so it will run these bits of code with the time equals 0.5, and then it will literally sleep for 0.5 seconds. But once this function is called, the await async IO sleep, what this is telling the code that is that, okay, if this function is sleeping, okay, there are still like resources available. Okay, why not you go and do something else first? Okay, so this count to 3 is sleeping for 0.5 seconds, right? So while this thing is sleeping for 0.5 seconds, let me go and execute this code first. This second count to 3 function with time equals 0.7 seconds. Okay, so that's why you see this part over here. So it will run the count to 3 code with a wait time of 0.7 seconds. So it says counting to 3, wait time 0.7 seconds, it will count 1. Okay, and the moment it prints 1, and then the count to 3 with time of 0.7 will wait again, this time for 0.7 seconds. Okay, this time for 0.7 seconds. Okay, then once you call the async IO sleep, yeah, what you're telling the code is, all right, this function can pause. Okay, this function can pause. Let me go and run the next function under my task list. So the third thing in the task list is count to 3 with time 0.9. So you'll print this thing again, print count to 3, wait time is 0.9 seconds, and you'll print 1. Okay, so that is what you are seeing here. Okay, so once this thing is run, okay, once this thing is run, again, you will run into this await async IO sleep, and then this wait time is 0.9 seconds because we are running count to 3 with time 0.9. Okay, now that we have finished all the tasks, we can actually move back. Okay, we can actually move back to async IO gather will say, okay, what's the next thing to do? Okay, do I still have any tasks left? Well, I don't have anything else to do, so let me Let me just wait the other 0.5 seconds. Then we can execute the first task again, which is count to 3. Okay, so after this is done, count to 3 will go. Okay, it will sort of go back to this code here. It will go back to this code here. Okay, so it will go back to the first function and it will pick up where it left off. So you'll pick up where it left off, so you'll wait the full 0.5 seconds and you'll print the number 2. So it will print the number 2, which is this number 2 over here. Now, of course, when you look at this code, there's no way, literally no way of telling you which number 1, which number 2, and which number 3 this belongs to. So how do you like help in this issue? Well, we can just do another print code. Print, okay, waiting for, and then I will do string time, and then I'll put the seconds. Okay, and I'll copy and paste it here as well. So that's literally what it does. So every time you see the input, every time you print the number 2 and you print the number 3, it will say waiting for how long, right? So if you, for example, if you give the time equals 0.5, you will be able to see the waiting for 0.5 seconds here. So this is the way to know, okay, which count to 3 function is being run at which time. Because when you give different inputs, 0.5, 0.7, 0.9, or rather here, 0.5, 0.7, 0.9, you will be able to tell which instance of the function you're running, or which instance of the coroutine you're running. So let's do that. So this is the serial way of doing things. So it will run the code one at a time. Okay, but this is the coroutine way of running it. So again, we run the first parts of the code because when async IO is sleeping, or you run that function and you run it in the context of doing this async IO gather, you'll say, you will look at this and I'll say, okay, I can, if this thing is waiting for me, if this async IO sleep is being called, it means I can go and start doing the other things on my task list, right? Count to 3 is over here. Okay, count to 3 is here, and its time is 0.7. So, okay, it will have a wait time of 0.5. And while the wait time is going on, you can go and execute the second piece of code. Okay, and then it will run the async IO sleep wait again, and then async IO sleep will be run, and you're telling Python that, okay, let me go and do another thing on my list, and this will be the third one. And then it'll be here. This is the third thing. And then once you execute these lines of code, it will come back to this wait function again, and then it will say, okay, I've done all my 3 tasks. Let me go back to my first task and sort of check. So sort of check whether this thing is still running, or does it still need to wait. Okay, so since it still needs to wait 0.5 seconds, it will wait the literal full 0.5 seconds. So you wait the full 0.5 seconds, or this count to 3. Okay, you wait the full 0.5 seconds, and then what happens? Okay, then you run the second. You run this bit of code here. Okay, print to waiting for how many seconds? So once you run the first fraction of these 3 pieces of code, you go back to the first piece of code. Go back to the first coroutine, and this one is the count to 3 with the time 0.5. So you'll print 2, and you'll say waiting for 0.5 seconds. So see, that's what's happened here. Then what happens next? It will run into another async IO sleep, which means, okay, the async IO gather will get a signal that, okay, I can then look at the next thing on my task list. The next thing on my task list is count to 3 with time equals 0.7. Okay, we count to 3 with time is 0.7. Okay, what's next on the list for that coroutine? Print 2, print waiting for string time seconds, then await. So it will do that. And then it will print this part. It will print this part of the code. And then it will wait for 0.7 seconds. But in the meantime, async IO gather will get a signal that, okay, this function is sleeping. Let me go to the next thing on my task list, which is count to 3 times 0.9. Then the time 0.9 count to 3 function will print the number 2. It will say waiting for 0.9 seconds, and then it will sleep for 0.9 seconds. So that's the thing over here. Okay, then you repeat the same thing with the number 3 series, because literally it's the same code, but instead of printing 2, it prints 3. So so it counts 1, 2, 3, 1, 2, 3, 1, 2, 3, and then here is where you count to 3 so-called concurrently, when you use await sleep and await async IO gather. So hopefully that demystifies to you some of the basics of why you need to have async IO and what's the usefulness of it. Okay, it's basically you can run so-called functions. You don't run them in parallel per se, but you run them asynchronously, meaning to say you can run the first part of this function, and then of course I can go and do something else. I run another function, and then once this wait time is over, you come back and then I run this part of the function, and then you say wait again. And once it's waiting or sleeping, I can do something else, and then I come back again. So this is running asynchronously. It's not in parallel, but it looks like you're running the same 3 functions like in parallel, but that's not actually happening. This is asynchronous running. It's not really running in parallel. Okay, so it's not 2 computers or 2 processors doing exact same function, but rather it is 1 process, but you kind of run the functions simultaneously, or you run them asynchronously, meaning to say you run different fragments of the function at different times. So that's the usefulness of await and the whole idea of asynchronous functions. Okay, so thanks for watching. I'll see you again. Hopefully that clarifies what this whole thing is about.